Hello everyone, good afternoon. A very warm welcome to everyone joining us today for our insightful Maple webinar, Applied Mathematics Meets Modern Physics with Maple. I'm Nityashri, data analyst and Maple expert at Binary Semantics, and it's my pleasure to be your host and one of the speakers for this session today. We have a truly distinguished panel of experts joining us today. It's an honor to introduce Professor Dr. Shyamkant Anwani and Professor P.K. Ahluwalia, sir. Welcome to the webinar, sir. Dr. Anwani is professor and head of the Department of Physics at Sri Shivaji Science College. He has 29 years of experience in teaching and research in physics and brings a wealth of experience in computational physics and computational oriented courses entitled Mathematical Modeling using Maple and much more. Also, additionally, he is the president of the Sub-Regional Council of the Indian Association of Physics for Vidarbha and an executive committee member for Maharashtra state. To introduce Professor Ahluwalia, he as well is a distinguished figure in the realm of physics, I can say, and having served as a revered educator at Himachal Pradesh University, Shimla, before he got retired. So throughout his illustrious career, he has held numerous pivotal roles. He has made significant contributions to the field of mathematics and physics through the organization of numerous academic conferences, and his involvement in various scientific societies includes his current role as the president of IAPT and executive member of the Indian Physics Association. So we are happy to have you all with us today, along with our esteemed colleagues from the Binary Semantics team.
Thank you.
Thank you, sir. So before going to the webinar, I would just like to introduce you all to our organization, that is Binary Semantics. Let me give you a brief overview of our journey. So binary semantics for the past 39 years has been a trusted partner in the technology landscape. Our foundation lies in deep technological expertise, allowing us to serve our global customers across diverse industry verticals. To talk about our technological expertise, we have technological expertise in digital transformation, data analytics, BI and AI, cloud, big data, cybersecurity, and we also are partnered with Microsoft, Click, SaaS, and of course MapleSoft. And also we are widespread in the different industry verticals, starting from BFSI, transport, and logistics, and even in the manufacturing, mining, tourism, and mainly in edtech and AI features as well. And we also have accreditations from MDEC, SOC, and ISO certifications. And this is just a brief about the 39-year-old binary semantics. To further talk about our portfolio offerings, our portfolio is quite comprehensive, reflecting our commitment to innovation and providing cutting-edge solutions. So this includes our suite of in-house products like Visoft, which is our visual inspection solutions, and GST Robo, our GST compliance automation tool, and Fleet Robo, our intelligent fleet management system, and our robust business intelligence solutions that empower data-driven decisions. We are also deeply invested in edtech solutions, recognizing the transformative power of technology in education. So now it comes our core pillar, that is the DAG, Data Analytics Group. Within DAG, we provide a range of powerful tools and services focusing on statistical analysis, optimization, mathematical modeling, and at the heart of our mathematical modeling capabilities lies our expertise with Maple. And we are happy to have you all with us today, along with our esteemed colleagues. And these are some of the academic offerings that we have. For statistical analysis, there is SPSS, and for optimization, there is Lindo Systems, Lingo, What's Best, and mathematical modeling, of course, the MapleSoft. And when it comes to MapleSoft, the MapleSoft portfolio is more than just a computational tool. It's an environment, I can say, that empowers researchers, educators, and students to explore, visualize, and solve complex mathematical problems with unparalleled efficiency. So, our Maple portfolio encompasses the full suite of Maple products, including Maple Desktop, which we'll be widely discussing today in this webinar, Maple Flow for intuitive calculation for design integration and design calculations, Maple Learn for interactive learning, and Maple Sim for physical modeling and simulation. We provide end-to-end support from licensing and implementation to training and customized solution, ensuring our clients can harness the full potential of Maple. So, to further talk about some of our clients, most of the private institutions, NITs, and research institutes like ISRO and DRDO are already users of Maple, as Maple's low code to no code interface makes it more user friendly amongst our wide users, I can say. So, this was a short glimpse about Maple and MapleSoft along with our organization. Now it's my distinct pleasure to invite our next speaker, Professor P.K. Ahluwalia sir, so that he can share his instance about his all insightful understanding of the role of computational tools in learning, how exactly it helps all researchers and students, and of course his extensive use of Maple in his academic endeavors would help everyone present here.
So thank you, Nitishri, and thank you, Binary Semantics, for giving me an opportunity to be present in this seminar. Currently, I am president of Indian Association of Physics Teachers, and we have about 10,000 members spread all over the country in different verticals, right from schools to universities and colleges. So this seminar, when I came to know about it, I really got interested in it. And I was very keen that definitely our members and teachers who are teaching physics at different institutional levels are exposed to the dimensions of Maple. If I recall, Maple has been a leader in what you call symbolic computation at one point of time. That is how I know about it. And in the last, I think, 10 or 12 years, things have changed a lot. And it is high time that we get to know what are the latest things which are there available in the Maple suite and how it can be useful to particularly physics community or the scientific community. I am looking forward to the expert talk by Professor Anwane. I know that he has been using it for maybe more than 10 years now, and he has been running some kind of very interesting courses under his guidance and teaching. I know that as we are moving into national education policy implementation, there are a number of initiatives which have come as a result of that. And one of those is the research element at the undergraduate level itself. And when one talks of it, uh, I think in the context of physics, modeling is the most crucial thing about which we should really focus and talk about. And once we get to know what are the tools available in the Maple, I think there is no limit to exploring physics problems in whatever branch it may be. Maybe we may find it in typical classical courses of physics like classical mechanics, quantum mechanics, uh, many body theory, and modeling of many particle systems. Those are the in things right now. And we know that as a result of this, there are a number of interesting research possibilities which are there available on the Maple suite itself. I think it has been one of the leaders right from the very beginning. And I was very much impressed by its various, you know, uh, possibilities in which on the fly one can sit down and do computation and model something on it. And I am sure that the participants in this workshop are going to get exposed to this via Professor Anwane's presentation itself. I am very happy that IAPT is a partner with the binary semantics about it, and I look forward to certain further things also on the platform of IAPT in terms of some short-term, exposures, 2-3 day webinars where we can talk at length about the capabilities of the Maple in the era of artificial intelligence. I know that there are a number of things which have been added to Maple suite to meet the possibilities of 21st century itself. AI is one of those. Machine learning is another thing if we talk in more technical terms. Thirdly, I think visualization part of any software makes things, uh, feel us that what is happening inside it. So when we have to churn out something out of the data which is meaningful to us, the Maple suite, I think, will be a great, great resource for each one of us. I'm sure that this session, which is going to be of great interest to mathematics and physics teachers and researchers and the students, uh, this will provide us a opportunity to really try our hand. And I'm told that there are a number of possibilities which are available for the users uh, very easily on a mobile phone even or on a laptop. I hope this seminar will provide us a peep into the heart of Maple and its development since almost, if I may put it, last 30 years, more than 30 years. So thank you very much for giving me an opportunity to be part of this seminar. And I look forward to the deliberations further. Thank you very much.
Thank you so much, Professor Ahluwalia, for those insightful perspectives on the importance of tools like Maple in education and research. Your experiences as IAPT president and a dedicated Maple user truly highlights its impact. So, before passing it on to our main speaker, Professor Anwane sir, I would like to begin with some of the brief interface of Maple and just showcase how Maple can be more user friendly. Maple 2025 being the new version, how its enhancements and of course the AI assistance and NLP in it has made an impact. I'll just showcase it briefly. I'll just walk you through. I'll be sharing my screen. So to first begin with, This is the main interface of Maple. As you can see, this is the main environment of Maple where we have two modes. One is of document mode and the other is the worksheet mode. Maple being a mathematical computational tool, it is more user friendly where it doesn't need more of a coding or programming knowledge. Just the subject knowledge would be suffice. And to talk about the two modes, the document mode is majorly for creating or editing any kind of question papers, creating assignments to students, or if they are researchers, they can also create their research papers in it. And to talk about the worksheet mode, it acts both as a documentation and as well as the virtual visualization sheet workspace. So I'll directly delve into the worksheet. As you can see, this is the main interface. This is the main interface of Maple, where in the left-hand side we have palettes and the right-hand side it's context panel. And as it is visible, the Maple has the ribbon kind of interface where it is easy to just click over whatever we are operating upon. And also, if suppose we are operating on particular expression or calculus or anything it is just a clickable interface where we can just get into the workspace by a click. Say, suppose I have given a fifth root of very simple random number like 34. You can see as per my input, the context panel just got changed. And according to this, I can approximate the values with 100 decimal 100 numbers after the decimal point and so on and so forth. So context panel changes as per my input. If suppose I give an input from a calculus palette, then of course there will be some other operations that will be visible in our right hand side. So say suppose I am giving a random triple integral as my input, then I'll give a function as x plus y plus z. Then of course you could just see when I gave an input of an expression that is the fifth root of 34, then there were other operations or options that we could perform. When it comes to integral calculus or calculus, we have n number of options where we can expand the same and we can integrate directly with respect to x, y and z. And also if suppose we want direct solution of triple integral x plus y plus z, then we can just click on enter in our keypad. Then we'll be getting the symbolic solution of the question, that query we have given as an input. So this is the user-friendly interface of Maple where we need not write lengthier code. That was what I was about to showcase with these simple examples. So if I talk about the presentation part, we can easily create such presentation in Maple itself as I have created. And there are also options of giving a slideshow of the same over here in the view. If I click on the slideshow, the same thing, we can represent it as a slideshow. That also comes under the view part. And to further explore some more in-depth calculus part, I would like to showcase some of the examples on differential equations. That is simple. If suppose I give a random differential equation like y double dash plus 2y dash plus y is equal to cos of x. This is a random equation that I have taken. You can observe, like, we need not write, there is no syntax or pattern that should be followed with Maple. Randomly, the way we write using pen and paper, in the same way we can just give the input and we'll get set of options that we can operate upon this particular input, wherein since I have given the differential equation and I don't know what kind of a differential equation this is, I can also go to the classify the ODE part, and it gives us a simple explanation in the worksheet itself saying the equation which I have given as an input is the second order linear non-homogeneous differential equation. And it will also redirect us to the help page where there will be set of options that will be available along with the examples, just in case we'll need some for reference. Or we can also create our own worksheet, as I have just in the new workspace, we can create our own worksheet as well. That is also possible. So this is one of the simple example of differential equation. To further solve the differential equation, I would like to show the numerical computation or symbolic computation. If we talk, then I have a equation which I'll be directly copying from the webinar worksheet I have created. So you can see I have given the input of y double dash plus 5y dash plus y is equal to cos of x. And in the right hand side, we have options of solving differential equation and solving differential equation interactively. If suppose we go for interactively, we get a dialog box where we have options of solving it both numerically and symbolically. Suppose if I give initial condition at y 0 is 1 and y dash at 1. These are random initial conditions I'm giving, and I'll just click on done. We have options of solving it both numerically and symbolically. If suppose I solve the same symbolically and give solve, the symbolic solution will be visible and along with the plot and the maple commands. All this will be visible, and upon quit we can get into any of the options. Say suppose I want to see plot in my workspace, not the solution that I have got, then I can click on the plot and give quit. Then in my workspace I can get the plot as well. These are very simple basics of differential equations. Of course, the second order differential equations and other things will be exclusively explained by Professor Anwani. And to further talk about some visualization part, which is very user friendly and also uh, helpful in understanding concepts, especially mathematical and physics concepts. Say suppose we talk about 2D plots and I give an input of sine of x by 2. We will get the plot option directly over here as well. And there is an option in the context panel where we can go to 2D plot and 2D implicit plot, where we can give the ranges for x and y. All these are possible. Say suppose I directly go to 2D plot, then the plotting will be visible in our workspace, and the same can be editable with the plot 2D taskbar, where I can add legends and also give some transparencies, the title, everything can be done. So these are some of the examples. In the similar way, there is a plotting for 3D plots as well, which I have already plotted. So I have plotted for sine of x into cos of y, where this is the 3D image that we have got as an output. This also is as similar as I showcase the 2D plot to execute. Just will be having a set of options where we'll have to select 3D and the ranges as well. So these are some of the examples on plotting. We also have, when it comes to visualization, there is not only the plotting part, there is also the animation part, I can say. Suppose I talk about 2D animation, where I have plotted a curve, or I can say surface on a parameter. That is, I have just taken a very simple curve. You can see we'll get a time frame as well, where I have set it to 10 seconds. And once we plot it by giving animate and plot as an option and giving x values from -4 to 4, you can see the animation of the plotting, like how exactly the curve on a surface or surface on this particular parameter works. This also could be seen. And the similar thing is done in 3D as well. So in 3D as well, the same thing is given, where I have taken the function as x square plus y square for the 3D animation. So all these need not require any programming knowledge. Just the subject knowledge of mathematics would be suffice, I can say. So these were some of the inputs on mathematical expressions. And when we come to some of the major features that Maple has, we have code generation assistance, which is majorly used by researchers who are using n number of programming language for their research. We have a code generation which assists us to translate from one input, that is Maple input, to other language output. Some researcher, he or she is working on R programming, and they have a Maple input, but they need a code in R for the same input. Then directly they can copy the input and paste it over here, and translate code from Maple worksheet can be done. By then they can fetch the output in their required language, may it be Java, Julia, R, Python. Most of the data related or statistical researchers, maybe big data researchers also may be working on Python or R, which will be easier for them to fetch it. So these are some of the key features of Maple. And to talk about Maple Cloud, the entire worksheet that I have created can easily be saved in the cloud, and that could be shared to any of the end users who don't have Maple. If suppose uh, any person who doesn't have Maple, they also can fetch the worksheet from Maple Cloud, while it will be in the viewable format for them. So these are some of the key features. To talk about math apps, the math apps in Maple are designed to illustrate various mathematical and scientific concepts. Say, I have created a link where it redirects us to the math apps. And in the math apps, we have applications that provide demonstrations related to mathematical concepts, starting from the basics of algebra, geometry, calculus to graph theory, even the trigonometry, natural sciences also is included. Once we get into any of the topic, there are subtopics related to that, which could be easily showcased, especially by the teachers for the demonstration purpose, for the great understanding, I can say. In such cases, math apps can be used, and the similar applications can also be created in using the new worksheets. So that is the main thing of Maple. To further talk about other than math apps as a feature, we also have application gallery that is being created. Say suppose there is engineering students or engineering professors, and they'll be working on application related concepts. In such cases, there are UI and environment examples that are documented where application center for the same is also being provided, and importing the data by data analysis and visualization concepts that also is available in App Gallery. And also some of the use cases like some real-time examples where vehicle ride and handling, how spectrograms works, how matrix in math and linear algebra can be programmatically visualized. In all these can be seen in this Maple portal for engineers. So to add further, I think the webinar thing is closed. Okay, to add further for the Maple 2025, we have AI in Maple. That is, as now Ahluwalia sir just said, now it is artificial intelligence era, and all our tools, computational tools, are into AI and ML. So even Maple has introduced AI assistance, which is more user friendly. With the palettes, I hope it is visible. I'll just expand it. With the palettes, we also have a tab called AI Formula Assistance, which is more user friendly. Say suppose we are working on particular concept like simultaneous equations, then directly we can give input in our AI assistance as simultaneous equations and give search. Any conceptual understanding or any formulas related to simultaneous equations will be displayed in the dialog box given here. So all this along with the description of basic simultaneous system, everything will be displayed. And we will also have a drop down list where we can select what particular topic we are looking into. And the same can be inserted in the worksheet as well. Say suppose I was looking into simultaneous differential equations and I need these two equations in my worksheet to solve further. Then I can directly insert the same and continue my solving using context panel, and the further solvation is as same as I showed in the beginning. So AI assistance is backed by ChatGPT, and we have n number of options. This was the very basic example I gave about simultaneous equation. In a similar way, we have n number of options that could be fetched from AI assistance. So these are some of the examples and a brief overview on Maple 2025, I can say. In the similar way, we also have an education tab where we have a student help center and many study guides for beginners as well as new users who can directly fetch all the study guides starting from the how to use Maple to how exactly we can make use of it. All these are available in the education center. So this was a brief overview from my end about Maple. Now I would like Dr. Anwane sir to please walk us through how exactly Maple can be helpful for both mathematics and computational physics.
Thank you. Thank you very much, madam. Am I audible?
Yes, sir. Yes, you're audible.
I'll share my screen. Is it visible?
Yes, sir, it is visible.
Okay, thank you, madam. So today with binary semantics, Shri Shivaji Education Society, Amravati Science College, where I am working in Nagpur, and IIPT. This is a joint venture along with Binary Semantics, and I'm going to showcase some MapleSoft programs, that modules that I have prepared for my learning and for my students. So I would like to address that Professor P.K. Ahluwalia sir, who is Central President of IIPT, executives of Binary Semantics, and dear participants. A very warm welcome to you all for this webinar, and we'll go through certain topics that we have decided and planned to showcase you. And for that, I'll have to take you to the Maple worksheet. Now, is it visible, madam, my Maple worksheet?
Yes, sir.
Okay. So here I have lined up some modules, those I have prepared, and I'll showcase you how the power of Maple can be used for understanding of the subject, displaying certain concepts to students, and that can be used for research also. So here, to save the time, I have keyed in the lines those I am interested in showing you as a bunch together. So restart is a common command that we normally roll through so that all the accumulators are cleared, and it's capable to store things in the fresh set of memory locations. So can you see this equation number 1, ax square plus bx plus c equal to 0? So this is a quadratic equation. If you write that equal to y equal
Sir, it is not visible,
Okay.
sir.
Okay, okay. Okay, I'll have to share in different window. Is it visible now?
Yes, sir.
Right. So here we have keyed in equation number 1. This has given a name capital EQ1. This is assigned as ax square plus bx plus c. And when we press enter, that equation is displayed in blue color. And then I want to solve this equation for x, that usually we do in school mathematics. So this has roots minus b plus minus under root b square minus 4ac upon 2a. So these two roots are visible with just a simple command solve, solve. What you want to solve, that is equation 1, and for x you want to solve that. Similarly, there is equation 2, ax cube plus bx square plus cx plus d equal to 0. Normally, we are not handling this equation because it has 3 roots and the roots are very long. They are unlikely long as in the case of quadratic equation. So we can ask Maple to solve that. And solution 2 is assigned as solve equation 2 for x. And here you can see the solution. So the first root you can see here. This is the first root. Then you can identify the spread over of second root to this comma, and then third root. Now we can consider left-hand side of equation number 1. Left-hand side of equation number 1 is ax square plus bx plus c. So I'm considering that for interactive plot. And you can see a dialog box wherein I'm asking for interactive plot with 3 parameters. X is rolling from -10 to +10, and in sequence we'll ask A to roll from -3 to +3, then B to roll from again -3 to plus 3. C will ask to roll from -10 to +10. And then we can preview what is happening. And I'll ask Maple to generate a plot command for display. And here it has generated the command. Now I'm copying this command and executing that command. Now that command that I have pasted here is in black color, and now it has executed the plot. Now all values are like balanced from -3 to +3 and -10 to +10. So if I change coefficient A to positive side, you can see a parabola opening upside. And if you take it on negative side, it is parabola opening on downside. If you scroll the value of B from minus side to plus side, you can observe what is happening to the curve. For A being positive, we can roll a value of B in negative zone and positive zone. So vertex is undergoing a change. And if I bring it to center, and then I'm changing value of C. So if I'm taking C negative, and the vertex is going below x-axis. Now, when we are talking about roots of the equation, here you can observe this will be first root and this will be second root. So this can be very nicely used to showcase students how the role of the coefficient plays in plotting any kind of equation. This we have done for quadratic. Then in the classroom, we are dealing with simultaneous equations. In mathematics way, I'm going to show in the next module. But here, from physics point of view, we shall consider the Bohr model. And there we have 3 equations. Increase the font size. So I'm running the basic command restart, and after that, I'm putting equation 1. The angular momentum is integral multiple of NH cross. So this is my equation number 1. Equation number 2 is the Coulombian force of attraction supply necessary centripetal force. Centripetal force we say mv square upon r. And here we have q1, q2, or you can say q square upon 4 pi epsilon 0. From palette, you can select epsilon, or you can straightly write down epsilon. When you are putting a square bracket, it gives suffix. So here you can observe equation number 2, where q square upon 4 pi epsilon 0 r square is equal to angular momentum mv square upon r. And the third equation is total energy, that is kinetic energy plus potential energy. Kinetic energy part is 1/2 mv square, and potential energy part is always negative, minus q square upon 4 pi epsilon 0 r. So here we have these 3 equations. They are tagged with equation 1, equation 2, and equation 3. Now I am asking a solution which is assigned to SOLN as solve equation 1, 2, and 3 for radius, velocity, and energy. So Maple is capable of solving that, and you can see in a single click in a fraction of a second, we are getting that required equation. Here in place of Q, we are normally using E, that is charge on electron. But here in Maple, E is reserved for exponential function. So I have to assign another variable Q to represent charge. Now, the energy levels we know that is minus 13.6 upon n square. in electron volts. So to obtain that, I am substituting charge on electron as 1.6 into 10 power minus 19 coulomb, mass of electron as 9.11 into 10 power minus 31 kg, and this is the value of epsilon minus 8.85 into 10 to the power minus 12, and this is the value of Planck's constant. Capital P small I, this represents pi, and it absorbs the value that is 22/7. So this is solution 1 is assigned with substitution of Q M epsilon 0 H into solution. So this will assign the required thing. So here you can observe this value is actually minus 13.6 upon n square, but that is appearing in joule. So to convert it into electron volt, what we'll have to do, we'll have to divide it by charge on electron. So just to show you the ability of Maple, I'm going to ask EVALF evaluation this number divided by 1.6 into 10 power minus 19. So this is now converted into electron volt. So we approximately consider that as minus 13.6 upon n square. So this is how you can explore Maple for calculations, precise calculations. I guess some participants are from mathematics background. So simultaneous equations, they are raising in a way A1x plus B1y plus C1z equal to D1. That's the standard format. And I'm going to execute that format also. So equation 1, when we are taking 1 in the square bracket, it is offering a suffix. Equation 2, equation 3. Now we are asking to solve this equation 1, 2, 3 for x, y, and z. So if you have insight into this last equation, this is fairly the Cramer's rule that we are using to solve simultaneous equations. Okay. So going on to the next module, I'm going to handle the basic first order differential equation we are using for Newton's law of cooling. So the basic problem I have picked up is if the temperature of the air that is surrounding is 30 degrees centigrade and the substance cools from 100 degrees centigrade to 70 degrees centigrade in 15 minutes. Find the temperature, find the time, find when the temperature will be 40 degrees centigrade. So here I have already written the code. I'm using that basic command restart. And as madam has said, we can use the palettes to call differential operator, or you can key in. And there are various ways to enter the equations. So DIFF, so I'm causing differentiation. And here I'm using on capital T is temperature, which is function of time. So T inside bracket T, and I'm putting here a comma and T. It means that differentiation of capital T with respect to small t. So this is the rate of cooling. So I have inducted minus sign here. This is some constant. Actually, Newton's law says that rate of cooling is directly proportional to the difference in the temperature of the object and surrounding. So I'm ruling this command. So it has written an equation the way we write in our copy. And then we can use the command dsolve. DSOLVE equation 1. So it will solve the differential equation and you can find the solution of the differential equation along with a constant C1. So to address that, we need to use boundary conditions. So BC as boundary condition is at time t equal to 0, the temperature is 100 degrees centigrade as stated in the problem. So boundary condition I am putting as t of 0 is equal to 100. And now the command is desolve equation 1 for the given boundary condition. So the syntax is appearing on your screen. So if you key in that, you will get the solution. So in this solution, C1 constant is eliminated out. However, K is appearing there. So you need one more boundary condition that is already given in the problem. And the second boundary condition is after 15 minutes. So 15 multiplied by 60 seconds. So after 900 seconds, the temperature is 70 degree. So that boundary condition we have inducted. And now what we are doing, we are putting values and solving it for K. So equation 3, we have 70 equal to 30 plus 70 into e to the power minus 900 K. So this can be considered for simplification to obtain value of K. And here as equation 4, we are having value of K. Now we can substitute this value into our basic equation, and actually this is complete solution. Now if you put in anything, if you put in time t, you will be able to obtain temperature at that time. And if you put in this temperature, you can obtain at what time it will be. So we are solving it for time. So 3129 seconds it will take to reach to 40 degrees centigrade. So we can ask Maple to plot right hand side of equation 5 in the range wherein we should be able to encompass our value. So here you can take it for 5,000 seconds. So you can see here, and at what temperature, at what time it will be 40 degree. So here this is 40 degree, and here you can observe the corresponding time coordinate. So this is how you can get into the differential equations. Simple harmonic oscillator is a very usual thing we are teaching into classrooms. And when it comes to differential equations, this equation, damped harmonic oscillator equation, takes about 1 hour to solve it on your blackboard. So here we are going to solve it very quickly. Here I am using a internal program of plotting so that I can plot the graph in the desired way. And ODE1, that is ordinary differential equation. So here you can observe that m is the mass, then second order derivative. So comma t, that gives you second order. You can write comma t as many times you want to get the order of differentiation. Then plus k into x of t, and r is some damping part, resistance part, that depends on velocity. So we are writing the differential equation, and once we run that command, you can see the differential equation the way we write in our copy or on the blackboard. Now we can desolve that equation and immediately it will give you the solution. And C1, C2 constants are nasty and I want to eliminate them. So here I need two boundary conditions. So x of 0 equal to 0. When t equal to 0, the displacement is 0. I mean to say that the oscillating object is at the center. So that displacement is 0. And the derivative of displacement at t equal to 0 is 0. So this is boundary condition. You can change the boundary condition and you will be able to get different values of C1 and C2. However, the solution is having the same flavor. So I am making a desolve command on ordinary differential equation 1 with the boundary condition. And what is happening? Okay. I should have been able to get the solution the way we have obtained. There's something wrong. I'll rerun the program from beginning. I think I could not get the solution. What should be the boundary condition? Boundary condition seems to be all right, but I don't know why it is not working. What I'll do, I'll try to rewrite the things. Actually, I have solved that and I'll explore that command. And here you can observe a value of M, R, and K, you can change the way you want. And if you change the mass, you can see the damping part, how it is, running out of oscillation. And if you reduce the resistance part, it will reach to that solution like undamped oscillations. So we'll keep some resistance part, and K will govern the frequency. So on the time scale, you can see how it is rolling. So this type of solutions you can plot, and the most important thing is by changing values of mass of the object oscillating, resistance part of that, and damping constant K, you can see how the system will behave. This is one more program wherein we can show growth and decay of LCR circuit. This is a simple LCR circuit having transient current. And here again, I have written commands, and I'm going to execute them one by one so that you also can understand the basic equation we are writing as resistance part R into I, that is dq by dt. Then L into di by dt, it will be actually d2q by dt square, and q by c will be the voltage across capacitor. So sum of all three voltages, voltage across resistance, voltage across inductor, voltage across capacitor, that should be equal to the applied voltage. So we can desolve this equation. It has immediately given you the solution with constant C1 and C2. And the similar boundary conditions we are executing here, Q of 0 is equal to 0. And derivative of Q of t at t equal to 0 is also 0, because as charge in the circuit is 0, current in the circuit is also 0. And we are asking it to solve the differential. See here, similar boundary conditions, you can find the equation is similar to damped harmonic oscillator. And here Q of t we have obtained here. And the same function for time rolling from 0 to 0.02 seconds for given condition, charging and discharging you can see here. So applied battery potential, you can change the way you want. And if you change the value of inductor, what will happen? If you change the value of resistance, what will happen, you can see. And if you change value of capacitor. So this is how we can get into these differential equations, their solutions, and plotting. Actually, in this plotting, what is happening? If you plot exponential of minus t and exponential minus of exponential of minus t, it will be like this. And along with this, you want to plot a sinusoidal sinusoidal curve, sinusoidal equation. We are plotting sine of omega t. Here omega is 5. So if we club together in this command, what I have done, exponential of minus t, that is positive side of decay, is multiplied by sine of 5t. So amplitude is exponentially decaying of what? Sinusoidal equation 5t. And this envelope, which we have seen in the first diagram, red color and this blue color, So I am simultaneously plotting them. So here you can observe that the exponential decay of amplitude, if it is imposed, what will happen? So it is represented by this red line, which is actually a plot of exponential of minus t into sine of 5t. So other two are just envelope that guides us how it will go. Similarly, if we increase frequency, here you can observe from 5, I have written 25. So it will have more oscillations in given time of say 5 seconds. So basically, similar thing is happening in LCR circuit transient decay. This is a similar thing to save time. I'll go ahead and this is one Lotka Volterra solution, predator and prey model. So X of t is population of a prey at any time, and Y of t is population of predator. So this is a pair of differential equation, which is depending on each other. We can call simultaneous differential equation, the kind of equation that Nithishri madam has shown you as an example, but that was simply a mathematical representation. Here it is in a particular model of predator and prey, and this DE plot directly I am calling. So this is the solution that is being plotted. So if predators are growing in number, the prey number will decrease, and predators will start dying because they will not be having food, and similar thing for the growth of prey. Population dynamics, I'll skip this. I'll go ahead with one interesting example wherein while teaching mathematics, if mathematics teachers are here and even physics teachers, we have learned in the 11th standard while learning calculus, the first derivative of the function is 0 if the function has either maxima or minima, and second derivative is negative if the function has maxima. So I have picked up a interesting function. You can note down this interesting function x cubed plus 4x square plus 2x minus 1. So in the given range, you will be able to see a maxima and minima of this function. And f1 is assigned as f suffix 1. I have obtained by writing in the square bracket, and simply a dash offered me derivative with respect to x. And if you equate the f1 equation with 0, you will be able to get a quadratic equation. From cubic, we are going to quadratic equation, and we can ask for solution. Solution of this equation is, there are two solutions. And if you want to see the numerical values of that, you can run the eval command. And here you can note down minus 0.27 and minus 2.38. These are the two values where the function first order derivative is becoming 0. So it can have either maxima or minima. To clearly know whether it is maxima or minima, you will have to find second derivative, and in the second derivative you have to substitute the values. So positive value means minima. So at this minus 0.27, the function has minima, and at the second point it has a maxima because of negative sign. And now what we can do, I have assigned the same function as g in terms of y, and we can plot this function. So here you can see this function has a maxima. I'll take a grid. So at this point it is a maxima, and the function has minima at this point. So we'll try to see function and first derivative. Now here you can observe the function is in blue color, and the point where function has maxima, the first order derivative is becoming 0. And where the function has minima, at that point also first order derivative is becoming 0. Becoming 0 means red line is intersecting with x-axis. And now we'll see the second order derivative simultaneously. So here it is very clear that the function which is now in green color has maxima at this point. Its first order derivative is 0 and second order derivative is negative. I think I have to cover a lot many points. 3D plots. This very interesting thing. I'll roll the commands with plots. I'm using this module and I'm plotting sin x into cos y. Niteshri madam has shown you this, and you can roll this to see the different perspective. So x into y will have 3D plot like this. So here I'm just showing you different 3D plots. Those are generated using maple command. So simultaneously, I want to see 4 curves, C1, C2, C3, C4, and simultaneously I have clubbed them together to obtain a nice figure or a graph, whatever you want to say. Now, animation is a very interesting thing that we often need to roll things in time or with some specific variable. And sine function and exponential decay of sine function simultaneously plot. One is not getting damped, another is getting damped by that factor. Exponential of e to the power minus t by 5. So this is a factor that is damping it. Then second thing I want to show you, sine function and sine of t in, and another function sine of t plus pi by 2. So this is a phase difference. The second quantity is ahead by pi by 2. Then if it is lagging by pi by 2, we can show this to students, and their learning can be more effective with this. So here we can plot cos of t and sine of 2t. So this is a Lissajous figure. Here, if you set 3, there will be 3 loops. Those will be cutting your x-axis. And if you put 2 here, it will have a different shape. But this has not been closed. If you take it 3 versus 3, it will be a kind of ellipse, circle. Fine. Amplitude being same, it is circle. Now, if something is falling free under gravity, 1 by 2 gt square normally, it is falling down. So its y coordinate is decreasing. So this animation will actually show you things happening on that scale. Fine. Madam, I'll go more for 5 minutes to showcase something more interesting.
Sure, sir. Sure.
So Lissajous figures, I have given you a brief explanation. Here, power in AC circuit. If the phase power in AC circuit is, what is that formula? V0 amplitude into sine of omega t multiplied by current I0 into sine of omega t plus phi. And if phi is 0, power delivered is maximum. And if change the phase, in green color, you can see the power dissipated that is undergoing a change. So we can show all these things to students so that they can develop a better acquaintance for learning, and they can have a better understanding. Julia sets, this is a very interesting feature of Maple to generate wonderful images, and this is iteration of complex number. And if you run embedded Julia sets, it is going to generate wonderful figures. So this is the first figure of Julia sets that is generated out of complex number iterations. Okay. I wanted to show you the Schwarzschild matrix calculations by the powerful tool of Maple. We need a lot of time to actually calculate these things on paper. So I'm using tensors module and differential geometry module coordinates. I'm using time and space coordinate. Instead of x, y, z, I'm using r, theta, phi, that is spherical coordinates. And sparse array matrix I'm using, and the diagonal elements I have set as suggested in general theory of relativity. And this is the matrix, and we can explore this matrix for tensor calculations, and it will give us, it is evaluating the complete set. And I'll show you the output. This is a long output. So the coordinate variables x1, x2, x3, x4, they are t, r, theta, phi. Then covariant non-zero components we have generated. Then determinant of covariant metric tensor, you can observe Christopher symbol of first kind, second kind, you can call. So we need to undergo long calculations. This is Christopher symbol of second kind. So we have explored all tensor features here, and the Riemann tensor where the components are non-zero. So total components are 16 in number, and out of that non-zero components are displayed R1212, R1313. These symmetric components are non-zero. We have Ricci tensor, and then we have the curvature scalar, Ricci scalar, and Einstein tensor we have generated. We can deal with Wiley tensor. So these type of calculations, huge calculations, you can see they are very easily done in Maple. Geodesic equation we can generate here. These are the commands I have set in series, and the last command will be capable of generating the geodesic equation for the same condition we have talked about. So I'm executing this Maple worksheet. It is under doing that calculation, and geodesic equation you can observe. So this is how we can roll through quantum tunneling. I want to show you one wonderful model that was available on MapleSoft website, wherein you can change the barrier width, tunneling of alpha particles, quantum tunneling. Gamow was awarded Nobel Prize for this theoretical explanation. Huge calculations we are doing for BSc final year students in nuclear physics. So the width of the barrier we can set, then potentials we can set. Here we want a square potential. The barrier height we can set, and V3 also we can set, but again we are going for a square potential. The energy of alpha particle is smaller than the barrier potential. So physical situation, nothing can escape. There was no classical explanation for this, but the quantum mechanics came to rescue of what is really happening, because alpha particles were emitted, and we wanted explanation for that, and quantum mechanics could provide that. So energy of the alpha particle is less than the barriers, and you can see animation of all parameters like mod of psi square, that is probability density, real part of wave function and imaginary part. So if we reduce the width of the barrier potential, the probability of tunneling goes up. So this wonderful animation developed in MapleSoft. I think Niteshri madam, I would like to stop here so that we can have some time for interaction with the participants.
Sure, sir. So I think we have covered a lot in a short time, starting from the power of Maple in mathematical computations to advanced physics with its new features in version 2025. So I would like to say, like any tool, we truly believe that tools like Maple are essential in bridging the theoretical foundations of applied mathematics and also advanced modern physics. So thank you, sir, Professor Anwane, sir, and also Professor P.K. Ahluwalia, sir, for sharing your valuable insights and your extensible knowledge with all of us. And as we have few minutes, now we can have some questions. Anyone can please feel free to type your questions into the chat box and we'll do our best to address the same.
Madam, one of my colleague has asked a question, Dr. Sugandha Khangar, that what is the cost of the software?
I think Devendra can handle this. Yes.
Hello.
Hi, Devendra.
Hi, good afternoon, sir. So the cost of the software depends upon the licensing type. What kind of licensing they want? It could be a
What are the
standalone.
options? What are the options like?
Options, if we talk about, sir, it comes with a standalone machine specific type, and the network license.
I think that Professor Ahluwalia and I was discussing, sometime I have discussed with Niteshri madam also, that to today's participants, you can provide some license key for some time so that they can really work upon it and realize the power of Maple so that they can plan for buying it.
Dr. Anwane,
Sure.
we really appreciate this thing. So just drop a small email IDs of all the participants where you want to give the trial license, and we can arrange the trial versions anytime.
Right.
And answer to Dr. Sugandha Kangar's ma'am, we have a lot more solutions, types, and licenses what we can offer to you. Devendra will give you a call, and definitely it will be beneficial for all of us to work out.
Right, sir.
Maybe, ma'am, you can just share your mobile number or something so that he can reach out to you.
Is there any option like people can log into your site and start exploring it for some time so that they can develop acquaintance and they realize power? That is also a wonderful option. जिस तरह अंग्रेजों ने हमको पहले चाय पिलाया, then we got addicted to that. So there should be some actual access, I believe.
Absolutely, sir. We are taking this as a suggestion from your side, and definitely we'll get back to you on this part by connecting to
Yes.
MapleSoft team, how we
Yes.
can do it.
Yes, yes. So we'll request the participants to float a request on some email. Niteshri madam, you can provide some email so that they can write you and request for some.
Yes, sir.
Absolutely,
Already,
sir.
Devendra Sharma has shared his email ID so that they can drop. Anyone who requires trial license can drop email to his ID and make use of Maple trial version as well. Sir, when you were talking about some of the topics, there was a question related to like boundary. When you were talking about boundary conditions, there was one of the students or participant, I can say, has asked if we can change the boundary conditions to non-zero, then
Yes,
is there a possibility?
that can be done. I'll just immediately do that. We'll go to some equation where we have explored the boundary condition.
I think the participant Akash Goravar, he had asked.
Okay. Okay. Once again, I'll share my screen and I'll showcase how we can change the boundary conditions. Is my screen visible now?
Yes, sir. Now it is.
Okay. So what we'll do, this another example I'll consider. Restart I'm running, then population growth. So in radioactive decay, we consider minus d dt of n. So here we are considering plus, so it is growth of population. So boundary condition is n at t equal to 0 is n0. So you can assign any value to that. And here you can see the solution. Now we'll substitute at t equal to 2 seconds. The number is doubled. So n of 2 is equal to twice n0, and that is how n0 is eliminated, and we can evaluate k, and we can deal with this. So we can always do that. For example, in this example, population of Nagpur, this example I have considered in my class. So it is prevailing here. So Sensex numbers in 30 years, in 2021, the population was 24 lakhs. And in 1981, it was 16 lakh. So this will enable me to calculate something. And then in 2021, what is the population? So here you can see the answer. But I want it for some other number, so we can do that. That is not a problem. So boundary condition n of 30 is equal to 24 lakhs. So here we can do it 34 lakhs, no problem. So the calculation will run. So I'm running this equation. Then k I have found here. So this is the value of k. And now wheresoever I am using that, actually I am using it like this. So here I am putting the value of k, and we can obtain the result. So after 40 years, population will be like this. If I want after 50 years, so it will give you another number. So this is all flexible. Actually, to save time, I have considered already keyed in a set of commands. Otherwise, I can smoothly roll that. On my YouTube channel, I have done this, and I can share the link of that also in the chat box. So till then, you can read another question.
I think only that was the question that was left unaddressed as of now. Like rest all were addressed as and then they asked.
So I'm giving you the playlist of the Maple worksheets that we have used. I mean, we have recorded while executing to students, so that the participants can go through those videos, and when you will be providing them some facility of accessing for some time, they will be able to explore that.
Okay, sure, sir.
Absolutely,
So
sir.
there were only that was the question that was unaddressed, and rest all were addressed, and there are no more questions that I can see in the chat. Maybe most of the participants have got idea on what Maple is, and they are very much eager to use the trial key once they get to use it. So I would like to thank you once again, sir, Professor Ahluwalia sir, and the knowledge with us. And thank you all the participants as well, along with the binary team. We have our manager Arun sir and deputy manager Devendra Sharma with us. Thank you for your support for this webinar as well, the binary team.
Madam,
Yes, sir.
actually, I wanted to post the link of my YouTube videos for participants.
Mm-hmm.
So,
Sure, sir. Please
Sure,
post
sir.
it.
And so definitely we are going to post on our social media page also. So there would be some details about this all playlist.
right.
Thank you so much, participants. Thank you, Dr. Anwani sir, Dr. Aluwalia, Netrashi, for this wonderful webinar on the Maple 2025.
Thank you. Thank you for arranging this. Actually, we are reaching out to many people outside our institute, and that is a powerful thing, I believe. We are reaching out to our colleagues and students. That's a routine thing we are doing. But through this platform, we could reach out to many participants. So I am also very thankful to you.
Sure. Is there further questions from the participants? We are still over here. We can address the same.
I think, sir, only Anwani sir has to share this.
Yeah, Anwar sir, please share that playlist.
Yes, actually, I am trying to go in that chat box, but I am not able to paste that link. So I'm trying to.
No worries, Dr. Anwani. Maybe you can share it to Nityashi and she can share it on this chat.
Right.
Perfect.
So we
So,
can
well,
continue here.
absolutely. So, shall we wind up this webinar?
Yes.
Okay. So, thank you so much once again, dear participants and the panelists. It really works a lot. I hope that there is a lot more insights which you got it from Maple and how does it really works out with the capabilities of the AI features. And for any further assistance or clarification, please do reach out to Nityashree Devendra Sharma, Binary Semantics Limited, for any further things. Thank you so much, sir. Thank you so much,
Sir.
team.
Thank you.
Thank you.
Nityashree madam, and thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, everyone.
Thank you.